Good day, everyone. You're welcome to my YouTube channel once again. As you all know, I'm Michael Ifani, your design lecturer. I'm going to be taking you on reinforced concrete design again, a topic called slab design loading. And you're going to be using BS 8110 Part 1 1997. First of all, let's talk about the unit weight of concrete. Unit weight of concrete depending on the code that you're using. So for now, we are using BS 8110, which is British standard. So we're going to be using 24 kilonewton per meter cube, this is constant. This is constant. Then the next one we have here is overall depth of your section, or depth of your slab. Most times we have 150 mm, 175, 200 mm, etc. Now this value that you're seeing here depends on the use of the structure. For instance, if it's a residential building where you have your hostels, the normal house where we live, can go for 150 mm as the thickness of the slab. Then for commercial purposes, your maybe hospital, general offices and all, can make use of 175. Then for, let's say, for heavy duties, for instance, you have your bridge and maybe factory and some other things, you can make use of 200 mm, and so on. All right, so from what we are now, the next one will be dead load estimation. We want to estimate the dead load. What are the things other than the dead load? Let's say, for instance, we have a concrete, and you need, before you can place anything on it, or you want your slab to carry anything, you need to estimate the total dead load of that slab, that is the self weight and other things that will also come on that slab. So for instance, now we have dead load estimation, then we have a concrete own weight or characteristic unit weight of concrete. Concrete own weight, that means what will be the weight of your concrete. You understand? That's what we mean by that. And in doing that, it goes with the thickness of the slab that you want to use, which depends on the use of the structure. For instance, now we are going for residential, and like I said before, we have 150 mm for residential. So I will convert it to meters, which will give you 0.15. Now, for you to get the concrete own weight or the characteristic unit weight of the concrete now, which is the self weight of that slab, what you just do, simply multiply the thickness of the slab that you're using by the unit weight of concrete. In our case here, we have 24 kilonewton per meter cube. So when you do that, you are going to have 3.6 kilonewton per meter square. All right. So the next one that we're going to be adding now will be characteristic weights of finishes. You have estimated your, the self weight of the slab. Now, not just the slab alone, the slab will also carry some other things. For instance, your slab will carry maybe under to carry paint, carry other things, maybe your POP, you understand. Then let's say you have your tiles, you have other things. Come to think of it, anything you can think of that will directly rest on your slab, can consider it as finishes. And most times we don't really have a specific value, you understand. You just pick a value within a reasonable number. You understand. For now I'm picking I'm using 1.2 kilonewton per meter square. Don't worry, if you're in Nigeria and you want to design something like that, you can actually use 1.2 and you'll be fine. Should you get so? Let's put that. So I'm going to be using 1.2 kilonewton per meter square. That's for the finishes, your tiles, your paint, your POP that comes directly on your slab. Then the next one is partition allowance. What do you understand by the word partition allowance? Partition allowance is just like your, how will I put it? There are some blocks that comes directly on top of your slab. Maybe for instance, now you already have a space. And there's need for demarcation. There's need for partition. And it's for you to maybe to create your toilet, to differentiate your toilet from your bedroom floor from your sitting room and the likes. You understand? So the blocks that you use that does not really come directly on top of your beam, it comes directly on top of the slab. Those are your partition allowance. Those blocks, irrespective of the material you want to use, whether you are using a plank, you are using anything at all that you can think of, comes under your partition allowance. And most times there's no specific value for that. That is why it's called design. So you can use 1.5 kilonewton per meter square. That's for that. So then we have dead load estimation, right? So we have dead load in BS code. That is in British standard. It will represent our dead load by what? GK, G subscript K. So the dead load now will be the total summation of the dead load values. What is dead load? Dead load is just like is a permanent action or is a permanent load on a structure. You understand? Permanent load on a structure, they will continue to be on that structure till the last day of the building. So that we have it. The initial one was 3.6, which was a concrete unit, concrete own weight, that is surface of the concrete 3.6 plus 1.2 the finishes and the partition allowance, which is 1.5. You sum them together, you will have 6.3 kilonewton per meter square. Then the dead load now, that is for dead load, 6.3 kilonewton per meter square. We'll move down to life load estimation. This one you don't need to calculate for this. I'm going to attach a link to this video where you can see series of the values for life load depending on their use. For instance, now we are working on residential building. So the value for residential building, which is listed out, which you're going to see the link under this video. You understand? So it's 1.5. For instance, this for residential, 1.5 kilonewton per meter square. Let's say for instance now for office, for general use, you can see that as 2.0 kilonewton per meter square. So you can see them as 3.0 kilonewton per meter square, as the case may be. Alright. So if you're done calculating for your dead load, and you are done estimating also for your life load, the next thing that you need to do, the aim of this your design loading, is what you want to get is just your ultimate design load, which is value of n. You get the value of n, and in this case now we have n to be equal to 1.4 GK plus 1.6 QK. Now I'll quickly explain this 1.4, the meaning. This 1.4 that you're seeing here is just what we call partial factor of safety, which you will find in my first video, lesson 1. I explain what 1.4 means. Partial factor of safety is just like when you increase the amount of load. Now you can, if you look at what we have done so far, it's what that when we're trying to estimate for our GK, for instance now for we said 150 mm as the overall thickness of the slab. I'll show you that what your capital will be to form when they want to cast it or whatever they are going to do is exactly 150. What if it's more than that? You get, so that is for that. Then secondly, the finishes that you assume the value to be 1.2. I'll show you that the total value of the finishes that will come on the slab is exactly 1.2. You understand? Well, everything we are just doing is just assumption. There's a place we're going. So then the next one, the partition allowance, I'll show you that the value is exactly 1.5. So for us to be on the server side, it just goes, okay, we'll be like, okay, fine, let's increase our dead load by 40%. 40% of 1 is 0.4. When you add it to 1, you have 1.4. You get, so that's why we are multiplying our dead load by 1.4. That means we are increasing this value by 40%. That's for the dead load. Then for the life load now, the partial factor of safety, if you are in a university and they ask you what is the partial factor of safety for dead load, you can easily tell them is 1.4 GK, right? So then for life load, it's just 1.6 QK. That means the 1.6 now for the QK, when I said I'm going to release a list. If you have gone through it, you will discover that there are so many values there. Let's say, for instance, now the residential building is being designed for 20 numbers of people to be on that building. Now, let's say you don't really have power over the numbers of people that can come into that building, for instance, now. So maybe a place that is being designed for 20 people, we end up seeing 40 people on that same building, we end up seeing 50 people on that same building. Doesn't mean the building will go down. No, that is the question. So for us to be on the server side, we tend to increase our life load by 60%. It's a variable load, it's a load that it changes. You understand? What are the examples of life load? What are the examples of dead load? You'll get that in my video. Okay, so I have 1.6 QK, and so the ultimate load now will be 1.4. Your GK is 6.3 plus 1.6. Your life load is 1.5, and if you do that, you have 11.22 kilonewton per meter square. Okay.